Alright, this begins section 6.3 where we're solving systems of linear equations by elimination, also sometimes called addition method. This method is brand new. We've never seen anything quite like this. So you're going to be maybe a little bit confused at first, a little bit fearful of this method, but this is actually a really great method for solving equations, especially when we get bigger systems. So our steps here for elimination, also called addition, is to put the equations in the same form. They either have to be y equals mx plus b, or ax plus b equals c, or whatever. Whatever form they're in, they must be the same. Then we're going to multiply one or both. Now it's really important that you understand that it could be both equations multiplied by a constant, and our goal in the back of our mind is always going to be to eliminate one of the variables. So when we add them together, add the two equations together after we multiply, we want to add to 0. So that means numeric coefficients are going to have to be equal but opposite. And then we're going to solve the new equation that we just made in step number 3 for the remaining variable. And then we're going to take that solution back to an original equation, and we'll solve for the other variable, and then we're going to write our answer. So here we go. Let's just do this system. Example number 16. Now example number 16 is pretty nice because you see that the y here is positive 1 and the y here is negative 1. So all I have to do with this system is just add these two together. So there is no step 1. There is just a step 2, which is to no step 1 or 2. There's just a step 3, which is to add them together. So 4x plus 2x is 6x, and then 1y and negative 1y is 0, and then 9 plus 15, which is 24. And then we're going to solve for the x. So now we have x is equal to 4, and that was step number 4 there. And now once we have that value, we're going to take this value x equals 4 back to an original equation, either one of these. I'm going to put it back into my first equation, and solve for the y. And so that means I have 4 times my x value, which I found to be 4, plus y is equal to 9. And so I'll add the opposite of this. Remember, 4 times 4 is 16, so I'm going to add negative 16 to both sides, and now I find that y is equal to a negative 7. And so now I have my solution, my ordered pair. X is equal to 4, and y is equal to negative 7. Remember, you can always check that solution to see that it satisfies both equations. 16 minus 7 is 9, and 8 plus 7 is 15, so it does indeed check. And that's the process of elimination. So let's try it now with the system for you. Okay, so copy down this number 17 and then come back and check yourself. Okay, so you might have panicked here and you might have said, I can't do this. Okay, you get to choose, okay? Doesn't matter which variable you choose to eliminate. We choose one of them. I'm going to choose to eliminate y, okay? That's just my random choice. If you chose to eliminate x, yours is going to look a little bit different, but I choose to eliminate y. Okay, so right there. So I'm going to multiply by a negative 5 so that the numeric coefficients here are equal but opposite. Now I'm going to do this step. Okay, so now you see that I chose to do the first equation, so I multiplied all the way across. Don't forget across the equal sign too. So negative 20, negative 5, y, and then negative 5 over here. And then I add these two equations. The other one didn't change, so I just add them together, and I get negative 18 here, and I get a negative 4 here. These add to 0. And then I solve, so I get x is equal to 2/9. Now I'm going to take this back to an original equation and solve for the other one. And I'm going to go ahead and put it in the first one, and I'll pause it again and do it, and then you can see my result. Okay, so now you see I put that in for the first equation, put this in 1 in terms of ninths, added the opposite of the 8/9, and got y was equal to 1/9. And so now I'm going to write that as an ordered pair. We have 2/9 for my x value and 1/9 for my y value. And yes, those answers can be fractions. Now in the next video, I'm going to do it again with the other variable.